question, you know, I told you how it linked us to the vapor density and also to the other topic I taught you. This life, I was thinking that there will probably be somebody who will remember that concept. Of course, if some of you were struggling with a chemical formula, I find it, why would you not remember?
No, nothing is coming out.
The point is just that look at this question. A 1702 gram sample of a compound, which contains, now, idiot guys, they gave you the compound. They gave you the mass of the compound, but they did not give you the mass of the constituent elements.
Is that what I said?
A 17.02 sample of a compound which contains carbon, hydrogen, and oxygen only was burnt in a stream of oxygen. That means we carry it inside fire.
Exactly.
To produce carbon dioxide and water. That means inside this compound, what it produces carbon dioxide and water. When these products, chemistry, when these products were weighed carefully, not also you were weighed carefully, 40.2 grams of carbon dioxide was seen, 8.2 grams of water were produced. Then I say determine the empirical formula of the sample. They need the empirical formula, but the idiots did not give you the what? Fractional constituent of each of the elements that you will bring together to get the empirical formula.
That's what we need
now,
to find out.
The point now is this: if I think one most of you can struggle, one say, but can fail, but vocabulary in chemistry. I was just looking at you that the only thing you should have done is think: how do we get the constituent fractions of this element inside this? That's what we need to do. So how do we do that? I don't know if some of you remember there is a principle. Although that's not the principle we're going to use, but at least I want to remind you some principle that is a bit tantamount to the principle you are going to use. Principle that man don't know, or not play. Law of definite proportion. That's it.
Come on, shut up.
Using the principle of the law of definite proportion to get each of the mass of the samples you have here. However, if you had remembered, there's something that's also a bit related to it, which is the there's one law like this, mass, or when you want to get a percentage by mass. So I will not take percentage by mass. So you may not be able to use percentage by mass, but percentage by mass is also a bit tantamount to this guy. But what we are going to use here is what is called law of definite proportion. It's actually something that was actually created around maybe 1772. In that great grandfather would see his line. Great grandfather, they know his line, but probably my great forefather. Can you imagine that in 1772 not to protect this proportion? So how do we do it? You are going to now find each of the mass of the constituent element, those fractions, from the compound. We can find it. Simple formula, simple Faro-Jacob formula. So if I want to get that of this guy now, carbon, it has a formula. Mass of carbon. How do you get it? Relative atomic mass of carbon all over molar mass of compound. Now the compound where you find this carbon is molar mass of what? Of carbon dioxide. Relative atomic mass of carbon over molar mass of carbon dioxide times mass of carbon dioxide. Simple formula. By formula shall you be saved. Yes. So this is that when you no, you are wrong. Sister Joy, he shot you. That is what we call law of. So if you have not seen this guy before, now you have seen it. Now you have to go and recognize the concept. Because that is the concept we are going to use to get the individual mass of this fraction element that we have here. It's as simple as that.
I was telling you.
So, find the molar mass of carbon dioxide. Molar mass of carbon dioxide. Molar mass of carbon dioxide. So, ó jẹ́ 12 plus 2 open bracket 16. So, kí ló jẹ́ 16 times 2? 32. So that 12 plus 32 is what? 44 grams per mole.
No, I didn't say.
You know that when we want to do that of hydrogen, it's the same principle we are going to use for hydrogen. We are talking.
That formula is for
This for
Law of
carbon.
definite proportion, my brother. Law of definite proportion. Relative atomic mass of the constituent element over the molecular mass of the compound where you find the element times the mass of that compound. O gbọ́dọ̀ memorize it, my brother. For chemistry ṣe rí nìyẹn. You know, for guys who don't know more, they didn't teach you. But now you are now a Medulla Master Academy. So you have to memorize this concept. It's very vital. It's imperative. It's tantamount to the success. And you know the why? In JAMB knows that you have upgraded. You can't expect JAMB in all the questions they will be giving you. That they will now be giving you questions where they say carbon is equal to 99%. Hydrogen is equal to chemical percent. But no, they will give you the question where they will expect you to go and look for the constituents carbon, hydrogen, and what? Oxygen. It is typically this kind of question that you should be expecting inside JAMB. I've told you, JAMB concept. Once you understand the concept, you don't have a problem. So you have to understand. Ọ̀pọ̀lọpọ̀ máa ṣiṣẹ́ panasharp, máa lo panadol, máa jẹ́ olódò, jẹ́ osharp. So, can you see now that if you do not understand this question you correct, kí ló ń ṣẹlẹ̀? They did not give us carbon, they did not give us hydrogen. How did they expect us to find the empirical formula? So, next one we now find is that mass of hydrogen. Abibeko, yes. Now go and find that of what? Hydrogen. How do we get that of hydrogen? The same formula. RAM, that's hydrogen gas. RAM, hydrogen gas, all over molar mass of H2O. So that is the compound where you find the what? Hydrogen. You know what? Times mass of what? H2O. Formula. Wàá kó formula yẹn sọ́pọ̀lọ́ ni ó máa hot lórí ẹ̀. So by doing that, RAM of H2O is what? Is 2. Are you getting me now? I've not even found. No, let us first find the molar mass, just like I did that of carbon dioxide. Molar mass of H2O. Of course, everybody knows that that is what 2 times 1 plus what 16, which was what 18 grams per mole. So now let us now find the mass of these constituents, guys. So mass of carbon now will be equals to now. What is the RMM of carbon? We all know is what? Is what now? 12 all over. Molar mass of carbon dioxide, which we got, which is what? 44. Times the mass of carbon dioxide in the question, which was what? 40 point what? 40.2. Somebody help me punch the idiot.
That's
10.9 grams. So therefore, we have 10.9 grams of carbon inside that guy, inside this guy here. Carbon inside here is 10.9 grams. You see? So now, mass of hydrogen will now be what? 2. That's RM of hydrogen gas over molar mass of H2O, which is what? 18 times mass of water. What's mass? What's mass of the steam? Steam that was produced, what is the mass? 8.2 grams of H2O.
Like, sorry, mass of H2O.
I didn't get it.
Mass of H2O.
Of H2, I didn't get it. Only, okay, thank you. So, which is equal to what? Times what? Times kilo 8.2. Oh yeah, ẹ bá mi punch here. Please, ẹ má jà ṣe mistake o. 0.91 kilograms. So that is that of hydrogen. So now, don't forget that it is a compound that contains carbon, hydrogen, and oxygen. So, and they've given you the total to be what? 17.02 grams. So that means to get that of oxygen. To get that of oxygen, so mass of oxygen.
So wait, let me zoom it now.
Oxygen, okay. So mass of oxygen. This guy, you need Jesus. So mass of oxygen now. So mass of oxygen will now be from the 17.02 gram. You will now subtract the addition of what? That of carbon and what? Hydrogen. So killer get with the carbon down. The carbon down.
10.9.
So 10.9 gram plus what? 0.91. Oh yeah, add that one. 10.9 plus 0.91. Subtract it. That will be 17.02. So you subtracted everything. Okay, this one is 11. So 17.02 minus 11.81. So if you subtract it, so that means mass of oxygen is what? 5.14. So therefore, I will punch it myself.
5.21.
So this is 5.21.
Yes.
It's not 5.14. Connect it. 5.21. So that's 5.21 grams. So let's go, guys. So for that one out. So carbon. So what is the mass of carbon? Answer. What's that the mass of carbon? 10.1. Where is it? 10.9. That of hydrogen is what?
0.91.
And then that of this guy is what? 5.21. So what's the first thing? So this is exactly to be able to get these guys. That was why they have to undergo the law of multiple proportion or definite proportion rather. You understand now? That's why we have to undergo that process to be able to get this individual fraction of the compound. So therefore, you now do what? Divide by the what? Divide by the what? What is the first thing you're going to divide with? By the lowest. So the lowest number, don't worry, God will touch you. Lowest number. So what's the guy? I thought it was this one is 0.91 divided by what? 1. And this is 5.21 divided by 16. So please, what is the answer?
0.908.
0.908. This is 0.91.
Yes.
0.91.
Yes.
This one is what?
325.
So divide by the lowest. So it is here that you now divide by the lowest. And the lowest is what?
0.9.
So 0.91 divided by 0.33. 0.91 divided by 0.33. 0.33 divided by 0.33. So what's that here?
2.75.
Yes?
2.75.
That's 3. This one is representing what? Push it. Crochet 3. And this one is what? 1. So therefore, your empirical formula is what? C3H3O1. And that is the answer.